Welcome back. So, based on the idea about ammonia coming out from the green renewable source, there are a lot of projects comes out across the world. The first one is the Saudi Arabia. Their project is called NEOM, Green Ammonia Project. The project is expected to complete in 2026 and will produce 1.2 million tons of green ammonia per year. The facility will be provided by renewable energy and will help reduce carbon emissions by 5 million metric tons per year. So, the world's largest green ammonia initiatives, the company NEOM in Saudi Arabia initiated. The project is going to be completed in the year 2026. They are claiming that they are going to produce 1.2 million tons of green ammonia per year. The facility will be powered by renewable energy and will help reduce carbon emissions by 5 million metric tons per year. In Australia, they are huge money is invested for producing large-scale green ammonia. Projects like URI project in Western Australia and Coast Clean Energy Innovation Hub aim to utilize the country abundant solar because we know that out of the solar irradiation across the world, Saudi and Australia, the intensity level is very high. So there is a lot of solar energy potential available. They are harnessing it. And you can see that in every house in Australia, the solar PV and solar hot water facilities are available. So they are making use of the harnessing the solar energy to the maximum level. And wind energy also, they are not leading, I can say, producers of energy from wind source, but they are also working on wind to produce the green electricity for producing the ammonia. So countries among Europe, Norway, Denmark, and Netherlands are leading countries of producing the green electricity, I can say, which can be used for producing the ammonia. In Norway, Yara International, one of the world's largest ammonia producers, is working on decarbonizing its existing ammonia plants by transforming into a green hydrogen. Then in Denmark, Halder Prof is working on green ammonia project powered by offshore. You can see that in Norway and Denmark and Finland, if you go to that, if you have a chance to go and visit the countries, all houses are well connected with maximum harnessing of green renewable energy. So every house they have, I can say solar PV, or I can say the small windmill for a particular zone itself, and then they are making use of the biogas also to for cooking. So these are the three countries are leading, I can say, usage of renewable energy, particularly solar, then the biomass and biogas. And Japan's green ammonia initiative, Japan is heavily investing in green ammonia as part of its broader strategy to decarbonize energy and industrial sectors. The Kawasaki, you know that the company, heavy industries, collaborating with various partners to build green ammonia to supply chains. The purpose of producing ammonia is not only having the application in terms of fertilizer, it also has the great application in the refrigeration air conditioning area. And also it carries the ammonia can be used in engine directly, or it carries the hydrogen. Wherever you need hydrogen, you can use the green ammonia, which can be used for converting the hydrogen. So ammonia carries hydrogen. It is one of the best methods to store hydrogen. The United States, several projects are emerging in the US, including Monolith Materials, which is developing green ammonia from renewable hydrogen and carbon black. The US Department of Energy is also funding research in green ammonia technology. So you can see that in terms of energy, now the green, I can say, energy, hydrogen or green energy projects are emerging across the world. So Indian green ammonia projects, India is a major ammonia. As you know that India is the number 2 in producing ammonia from the Haber-Bosch method. The first one is China. So we are already having the potential of producing ammonia. Facilities are available to produce ammonia, which can be utilized for producing the fertilizer as we have our country is now purely of agricultural background. So the ammonia plays a major role in cultivating the per acre of land. If you're using ammonia fertilizer, that the yield is when you compare with without ammonia 40 times higher. So the World War and World War II history, if you know that, the problem happened with respect to the increase in populations, then the food scarcity happens. So Haber-Bosch, I can say particularly Haber, the scientist, I can say invented two things. One good thing is ammonia, another worst thing is chlorine. So he used this chemical agent, the chlorine, to kill many people in Germany. So he was not considered as a good scientist. Even after receiving the Nobel Prize, people are not having, I can say, accepting he's a good scientist. But he is, because of the Haber and Bosch is the person running the industry. By joining this Haber and Bosch technology, they are producing ammonia. After ammonia comes into the, I can say, market in 1930 or something, 1936 or something. About, I can say, that there will be increased yield of agricultural products. There is an advantage, and also he has involved in producing chlorine, I can say, which was used for killing many people during World War II. So yes, in 2021, ammonia plant in Bikaner, Rajasthan. Germany, Siemens and Uniper are working on green ammonia production as part of the country's green hydrogen strategy. Siemens is exploring ammonia used as a fuel and as a carrier for nitrogen. That's what I said. So producing ammonia not only to produce the fertilizer, but also for refrigeration and air conditioning application, and also it can use as a fuel, which can also carry the hydrogen. Wherever you want hydrogen, you can dissociate the ammonia by giving some kind of energy which can able to break the ammonia, and we can able to extract nitrogen and hydrogen from ammonia. Chile green ammonia development project, abundant solar wind sources they are found. They launched highly innovative fuels project to produce green ammonia and hydrogen. Oman, you know that there is a lot of potential of solar energy, and Oman has launched green ammonia as part of its strategy to diversify its energy sector. So recently in 2024, August 21, 2024, was Chief Minister Stalin and inaugurated the green ammonia plant in Thoothukudi, signing between this maybe the Japan company. They have signed on a memorandum of understanding, and about 160 acres of land was given to them for creating a green ammonia industry. To build up a cost of 36,200 crores, the plant will initially produce 200,000 metric tons per annum of green ammonia for exporting to Japan. So benefits of the green ammonia: no carbon is present in ammonia. So no CO2 will come out, no carbon monoxide will come out. So COX will not be coming out. Then renewable production, utilize green hydrogen and renewable electricity. Scalability can be integrated into many renewable sectors to produce the ammonia. You can bring, I can say, tidal, you can bring gasification, you can bring pyrolysis, you can bring solar. So whatever may be the renewable energy available, you can produce the electricity which can be used for producing the ammonia. Challenges: high production cost, more expensive than traditional ammonia. Energy intensive process, as I already said, you need high electricity to break the water into hydrogen and oxygen, which can be used as a raw material for producing the ammonia. You need an infrastructure requirement, need for storage and transportation. In conclusion, global green ammonia projects are critical in driving the transition to a low carbon economy. By leveraging renewable energy to produce ammonia, these projects can decarbonize key sectors like agriculture, shipping, and heavy industries. As green ammonia can also be used as a clean fuel and energy storage medium, it represents a crucial component in global green energy transition. Continued innovation, investment, and international collaboration will be necessary to scale up these projects and meet global climate changes. So these are the possible questions. Why the green ammonia is important in global energy transition? How is India contributing to green ammonia development? What challenges are faced in global green ammonia market? What is the role of green ammonia in decarbonizing industries? What are the technological barriers to green ammonia? If we are able to answer the first 5 questions, we are successful in implementing the concept green hydrogen or green ammonia project. So these are the assignment. You can make a note of it. Compare the analysis of global green ammonia projects. You need to work on it because GIAN, at the end of the GIAN program, you need to write the examination. So we are going to evaluate based on the grades, accordingly mark will be assigned. So divide the participants into groups and assign each group one of the 5 global green ammonia projects: Australia, Saudi, Europe, Japan, or United States, or you can bring India also. Identify challenges, consider challenges like scaling production, market demand, technology implementation, infrastructure. So by keeping all those things in mind, can do the combined analysis of global green ammonia. These are the references we have used for preparing the PPT. 5 references we used. I am thankful to my scholars for all helping me in preparing the PPT. Thankful to Uday Kumar, thankful to Gopi, thankful to Saravanan and Lakshmanan for tireless work in bringing this information in the form of PPT. Thank you so much. We'll move to the next lecture of tutorial. The different case study. So the tutorial successful green ammonia projects worldwide. Why they are successful? So the learning objective from this presentation, you explore key case studies of successful green ammonia projects worldwide to identify critical factors contributing project success, to evaluate the environmental and economical impact on green ammonia projects, to discuss the challenges and features prospective in green ammonia sector. So learning overview at the end of the presentation, you are going to know why we are introducing the case study, what is the key section, what is important in case studies. So group activity, comparative analysis, interactive questions and answer, and key takeaways. This is what we discussed. First one, so this thing already we have discussed. So the Saudi Arabian, this one, green ammonia projects, they are making use of the solar and the wind to produce the electricity, which can be used for using the electrolyzer to produce the nitrogen from water. Then they are using gas separation unit to separate out nitrogen and oxygen from the presence consumption methodology or cryogenic type of concept. We can able to separate out the nitrogen from cryogenic reactors. So nitrogen reacts with the ammonia reactor. We call this a Haber-Bosch reaction. The nitrogen reacts and produces ammonia. This ammonia can be dissociated. If you want ammonia, you can use it for directly into the different applications. So in some case, if you want nitrogen, you can dissociate the ammonia into the reactor. We can produce nitrogen, which can be compressed by using a high pressure compressor, which can be used as a fuel for transporting vehicles. So we can see that running this video.
In this video, we will delve into the details of the world's largest carbon-free green hydrogen plant. I will discuss the project's specifics, its environmental and economic impacts, as well as potential challenges. Oil has powered the Kingdom of Saudi Arabia for decades, but now Saudi Arabia is setting its sights on a new horizon. The Kingdom is embarking on an ambitious green hydrogen project. When completed, it will be the world's largest carbon-free green hydrogen plant. We delve into the heart of this groundbreaking project, exploring its colossal scale, revolutionary technology, and potential to reshape the energy landscape. This is not just a story of green hydrogen, it's a story of collective ambition, technological audaciousness, and the audacious pursuit of a cleaner, greener tomorrow. Green hydrogen is a clean and sustainable fuel produced by splitting water molecules into hydrogen and oxygen using electrolysis. This process relies on renewable energy sources like solar or wind power, meaning the production itself generates no greenhouse gas emissions. Unlike its fossil fuel cousins, green hydrogen boasts zero carbon emissions, a breath of fresh air for our choked atmosphere. It's the fuel with a conscience, powering vehicles without spewing fumes and fueling industries without sacrificing our skies. But transitioning to clean energy requires more than whispers. It demands action on a grand scale. NEO and green hydrogen. Company's project isn't merely a factory, it's an industrial symphony that will be powered by sunlight and wind. Its colossal scale will translate to a daily output of 600 tons of green hydrogen, enough to fuel thousands of clean vehicles or power industrial processes. Imagine that's like filling over 200 Olympic swimming pools with clean fuel every day. But to generate this green gusher, the project will harness the might of renewable energy. A tapestry of 4 gigawatts solar and wind farms stretches across the landscape, capturing the sun's relentless rays and the wind's whispering dance. This renewable cocktail powers a process called electrolysis, where water molecules split under the influence of electricity, releasing pure hydrogen, the clean fuel of the future. However, storing and transporting hydrogen presents a logistical hurdle. Thankfully, NEO Green Hydrogen Company has a clever twist in its story. They embrace green ammonia, a molecule that readily binds with hydrogen, making it easier to store and transport. Think of it as a hydrogen taxi, carrying the precious fuel to distant destinations. This ambitious journey hasn't been a solo one. A powerful triumvirate has joined forces to make it a reality. ACWA Power, a renewable energy leader, brings its deep expertise in generating clean electricity. Air Products, a global industrial gas giant, contributes its mastery in hydrogen and ammonia technologies. And finally, NEOM, the futuristic city rising from the desert sands, provides the vision and infrastructure to nurture this green dream. Together, these 3 giants have woven a technological marvel, showcasing the collaborative muscle needed. They will not just build a green hydrogen plant, they will build a blueprint for a cleaner future, one powered by renewable energy and driven by visionary partnerships. The NEO Green Hydrogen Company project isn't just a technological marvel. It's a breath of fresh air for our planet, gasping under the weight of carbon emissions. This colossal undertaking promises to be the champion, slashing carbon in vital sectors like transportation and industry. Imagine roads and skies devoid of the noxious fumes spewed by fossil fuels. Picture factories humming with energy, yet leaving the atmosphere pristine. That's the future NEOM Green Hydrogen paints, with its green hydrogen replacing polluting fuels in vehicles and powering industrial processes without releasing a single carbon molecule. It's like swapping out a gas-guzzling SUV for a sleek electric car, but on a colossal. In this video.
So Saudi already started working on this green energy production. And similar to that, we have India, Bikaner, Rajasthan, India's first integrated green hydrogen and green ammonia project. Going to be, we can say, established in the year 2032. They plan to produce 10 million tons of green ammonia and hydrogen per year. Project partners are ASME is planning to partner with IHI. Japanese heavy industry manufacturers, produces green hydrogen at a rate of 500 normal meter cube per hour, about 175 tons per annum. The global impact project will significantly reduce the carbon emissions. So brief, it's a video about the Indian perspective. This belongs to India. So in NIT Tiruchi, and we are created a facility for producing the green ammonia. So myself is the project investigator, and the team members involved here Uday Kumar, and from our department Panisulu, and Saravana is currently working on this project. Also, with that from the irrigation control. So we have received the solar PV from Green Energy Environment in Chennai. Date of installation is on the 18th of October 2023. The cost is around 6 lakhs. Total number of solar panels of each 500 watts, 19 tons was involved. Power output is approximately around 540. This is with respect to the solar PV. Solar photovoltaic we have in our institute. And this is the source for producing the electricity. We are using that energy for
producing the hydrogen, but we are not producing the hydrogen what others are doing. We are going to use the plasma technology, the recent technology. I can say it was also the work was patented. So we are not using, I can say like electrolysis process like anode cathode. We are going to create a plasma for high intensity lighting system where nitrogen can also pass it along with the lighting source. The nitrogen is produces the plasma. The plasma is going to, I can say, is for producing the hydrogen and also for the nitrogen what we are using for producing the plasma gas reacts with the hydrogen comes out from the water using ammonia. The simple system. So maybe you can, if chance comes, maybe in a couple of days you can visit our laboratory. We are producing ammonia very simple manner. We are not using Haber-Bosch concept. We are not using any high pressure reactor or high temperature reactor. We are simply operating the system very near to ambient and ambient pressure. So we are bringing the concept called plasma technology, how the solar radiation reaching the environment, right, through the air, right, creating the plasma, the ionized gas. So we are creating the ionized gas by using nitrogen, by creating the lightning effect, high voltage electricity is passed on that. So when we pass on the nitrogen, we are producing plasma ionized gas. That gas is used for, I can say, splitting as well as for joining hydrogen into ammonia. So these are the references we are used for the tutorials. So I think I thank Uday Kumar and Saravan for bringing this, and maybe you can include some videos so that for this one it's good for them. Okay. So any questions? And ultimately, why I put this one on the end is we are talking about I can say we are talking about Haber-Bosch, even then the green method we are using. But ultimately, at the end of this one, at the end of this one, so so at the end, we are producing the electricity from the solar PV, but we are as a researcher, as an industrial person, how to remove the concept which is already existing in 100 years. So here, I think we are completely eliminate the Haber-Bosch concept of bringing the catalyst, iron-based catalyst, and the temperature of 350 to 450 degrees centigrade, pressure of 300 to 400 bar, high intensity process by bringing simple plasma technology, where we are splitting the water into hydrogen, again combining with hydrogen with nitrogen, which can be used for creating the plasma. It's a very easy method. We can able to produce the ammonia very easy. And to separate out the ammonia from the plasma reactor, we are using a low temperature refrigeration system where you can maintain at -33. You know that is the boiling point of ammonia is -33. So all other gases will be not going to condense. Only the ammonia is going to be condensed with collected formula. We can use it. We can produce our own ammonia in each house also. In each industry, you can able to use that ammonia for running the generator. Nobody will questioning it because it doesn't have. Thank you so much. Do you have any questions?
So what kind of method you are used for the plasma generation, sir? What kind of electrode, sir?
Normally we are using tungsten and other type of materials. But
for working as well as no electrode have been used for tungsten.
Tungsten, but also we have the another pattern where we eliminate the tungsten with a low cost copper. So we have a pattern for low temperature plasma, so high temperature plasma. High temperature plasma, Uday Kumar research is on high temperature plasma, where he has used biomedical waste without segregation of the any waste, wood or steel or bones or blood or whatever it is comes out from the, because there is a different bags available in the hospital, right? Yellow bag, red bag, black, so many things are there. The problem is when they are segregating the waste, there's a lot of issues going to happen. Unfortunately, some samples may be mixed with something and it's going to happen to the people those who are handling. So in order to eliminate that, we have found the method in which the plasma, high temperature plasma, we can go up to 3000, 4000 degrees centigrade. Where we can be eliminating the high cost tungsten into, I can say, low cost carbon tip to create a plasma. So if there is no issue of, I can say, segregating the waste, you can burn out completely. Even steel, bone, everything will be combusted. So you can convert into, I can say, gas. Some condensable gas, you can use it for some application, right? Condensable gas, nothing but a liquid. We can store it and use it for some application. Non-condensable gas, you can use it for thermal application. So every hospital need a heat. So the non-condensable gas, you can use it for producing the hot water or steam, which can be used for cleaning or washing or maybe the treating with the steel or whatever the thing, right? For cleaning and things. Whereas for condensable liquid, you can convert into liquid. You are converting waste into energy. So you can make use of it for running a generator, or you can sell it to the agricultural field where they are going to run the agricultural farm by using a diesel or something. So where is that, right? We can use it. So we have the high temperature plasma concept also patented, low temperature also we have. It's available. You can explore it. Maybe you take it to the laboratory. There you are if you are interested, you can even the sample will be given to you. You can load it and you can test it. Okay. So maybe some of them are coming from industry. Suppose they want to take this, I can say our idea into a big scale and contacting with the medicals, want to convert it to a product. Are most welcome. We are ready to transfer the technology. Thank you so much. Hopefully we'll meet tomorrow. Morning session and short set.
Yes,
Thank you. Have a nice day.